Welcome to my project demo for Visualization Lab 2A, done for the course CSE 564 under the guidance of Professor Klaus Muller. So, through this assignment, the main goal were to plot a scree plot. So, scree plot is basically plotting the PCA components which we got through the dataset. We'll go more into detail when we look into the scree plot, but the one of the goal was to plot scree plot. The other was plotting biplots. So just plotting the data points against the two major PCAs that you got through PCA analysis. That's a biplot. It's basically a scatter plot and a line plot combination, and also doing k-means clustering on the data points or data sets that you have that you have used during the project. So starting with the data set is the same data set used in the first project. It is the attrition data set from IBM HR, which can be easily found on Kaggle. I think I will just paste a link over that in my project report as well. So that's the same data that I'm using. So the initial stage was in the initial stage it was like we don't need categorical data. So a pre-processing was done on the data set to remove all the categorical data sets and just keeping the numerical data points that we have in the data set. So I think after removing all the columns which were categorical, I think it was around 14 columns that were left to analyze the data on using scree plot, biplot, and k-means clustering. Uh, this is what you see as a landing page for my project. It's simple. It is again a bootstrap template that I used in first project. There's a side nav bar detailing all the navigations that you can do, some detailed description about what I am doing using scree plot, biplot, and k-means clustering. Yeah, this is similar to what you can find in Wikipedia. If you want to read, you can go over it. But yeah, let's go over scree plot. So I think this is the page when you just hit scree plot. So scree plot. So this is a scree plot which you can see. So this is displaying different PCAs that are available. So that when I said 14 different numerical values in my data sets, they all will be associated to a PCA. So I think PCA1, PCA2, PCA3, and PCA14. So this is the scree plot that has been created. So I have kept the dimensionality index. So one of the goal of the project was the user should be able to select the dimensionality index. So currently the dimensionality index for the scree plot is 14, which is by default selecting all the columns that are available. So as you can see, if I keep 14, every sum of square loadings will always be 1 for everything. And this is, I think, the scatter matrix. Scatter matrix is plotting the max or the top 4 features, which has the maximum sum of square loadings against each other. So you see this is plotted against this. So you see a 4 by 4 matrix. 4 top say features plotted against each other. That will give you a 4 by 4 matrix. And yeah, this is what you can see. And there is another toggle which says color clusters. So I think yeah, to know about this, I think we should first go over the k-means plot. The k-means plot is basically plot trying to show the data clusters, how many optimum data clusters that you can create over the data set that you have. So I think in scree plot and in biplot, you have this option of color clusters. So I probably think that this is the first thing that you should be knowing about. So coming to this, so I think to display what's been done here is I think we have what I've done is I've used the elbow method available in Python to generate the data sets or data points for the data set that I have. So these are all the distortions values that I have plotted against the clusters that I have. So for one cluster, the distortion level is 2, 1. So this is some 3.8. For 2, this is some 3.2, and similarly as we can see. So I think elbow plot is something where you can see there is a elbow being made. So you see here there is a jerk, and you see this point is actually the elbow point. So this is what 4. And if you go over this, I think I have plotted a perpendicular line for better visualization, uh, saying that this 4 is your elbow point. So elbow at 4 means you can optimally create 4 clusters. And after 4 clusters, when you try to create using k-means, it usually doesn't give an optimized result, and it might get stuck in a local optima. So I think 4 is the best guess or best cluster count that I can have in my data set. So that's what this elbow plot shows. So this is number of clusters versus distortions. So labelings has been taken care, and I think yeah, the plot also looks good. So let's go back to C plot. So you see this again, coming back to this toggle. So color cluster is basically coloring this scatter matrix using the elbow method. So using the k value that we got from the elbow method. So if you just toggle it on, you will see, okay, there are 4 clusters being created and there are colors being populated for all the 4 by 4 matrices. Um, if you just toggle it off, it will go back to the normal. So sorry, one of the ask was the user should be able to select the dimensionality index on say dynamic level. So what I've done is made this bars clickable. Sorry. So these bars are clickable. So if you just click it, so let's try over PC7. Okay. So I clicked on PC7, the dimensionality changed to 7, and my features also changed. So you see, sum of square loadings has changed, my features also changed, and my scatter matrix also got changed. If I just color it again, I can color that again. If I want to select PC11, I can select PC11, and similarly, I can have different values of sum of square loadings and different features available. So this is interactivity. So you see the age. This is a new feature that came in. Total working hours came in, and you see there is a different set of clustering being available. Similarly, you can do color and decolorization. So when you select it, the dimensionality index here would be changing. Similarly, whatever you do PCA 12, PCA 14, it will just change, and your data will also change over the scatter matrix. So this was the ask of, I think, for one of the tasks where you need to have say dynamicness to select and give user an ability to select the bar graphs or the PCA or the dimensionality index as it says, and it should update this table which has the top 4 square loadings and also update the scatter matrix, which is being done. And as you can see, it's been correctly done via the plots and graphs. Coming back to the other graphs, that is the biplot. I think we have 3, right? We saw k-means clustering, we saw scree plot, and I think the last one is biplot now. So biplot is basically plotting all the data points that is available to you against the 2 axes, which is PC1, which is here. You can see PC1 and PC2. So also here labeling has been done. So you see 0, 1, 0, 5, 9, 10, 11, 12, 13. So you see age has been given, daily rate, distance. So these are all the feature name and labels that have been provided. This points are, I think, scaled down. So but what I've done is to make sure that all of these features are normalized, or maybe are in a normal scale, and you don't see points far away from each other. I have normalized them, and I have made sure that I use min-max scaler to normalize all of them, and so that my data points come between 1 and -1, and it looks pretty good. Similarly, there is also a feature to color the clusters using the elbow methods k value that we found. So you see, you color the clusters, the animation will pop in the colors and create the cluster. So you see one of the clusters here, the other cluster is getting formed here, second is here, and the third is the green one. And similarly, if you just decolorize, you want to decolorize it, you can decolorize it, colorize it. I can play around with it. I think more or less, I think the project is done. I think this is what the demo is all about. Uh, One, we learned about scree plot, one, we learned about the biplot and k-means clustering. Uh, Also, just to give a background on this project was done using Flask, few the B3 libraries, and JavaScript here and there, and using Bootstrap. So Flask was major component because last time we didn't use Flask. Here it was given we had to do some calculations and resource heavy calculations, it was, say, ideally good to use Flask, which uses Python as a backend, and use it. So it creates a framework using Python and used to use the same to, I think, render the templates over the web. So I think this is a kind of full end-to-end client-server web application that we have created, and which can be the basis to our say final project, which is due over the next months. So I think more or less this is the visualization lab 2A. If anything, please do let me know, and please reach out to me. Happy to share my thoughts and view on the same. Thanks for listening. Have a great day.